In this section, we're going to be evaluating algebraic expressions that have fraction bars in it. Now, I want to do several examples here, so let's go ahead and jump in. We have z plus 4 divided by 6 minus 2. And we want to know the value of this expression when z equals 3. Now, the main thing I want you to take away from this section is that when we see fraction bars that have more than one term in either the numerator, the denominator, or both, we treat these fraction bars in the order of operations as the parentheses, as a very first order of operation. It's kind of like a grouping symbol. We need to deal with whatever has more than one term in it, like the numerator here. It has two terms. We want to deal with the numerator first before we can actually carry out the division. Okay, so let's get started. We're going to go ahead and substitute the value for our variable z into our expression. So z, which is 3, plus 4 divided by 6 minus 2. Okay, we want to take care of the numerator first before we can actually do our division. So 3 plus 4 is 7 divided by 6 minus 2. All right, and here we have a rational number, so we go ahead, we know how to do this. We convert this to a rational number since we're subtracting. And let's just use our little cross multiplication for subtraction here instead of doing the common denominator. We have 7 times 1, which is 7. We're subtracting 6 times 2, which is 12, and 6 over 6 times 1, which is 6. If that confused you a little bit, go ahead and get a refresher on the subtracting, or actually adding and subtracting rational numbers, and that'll give you a little bit of practice how we came about with this. Moving on, 7 minus 12 is minus 5 over 6. Okay, so when we have a fraction bar, we're going to treat it in the order of operations as the same thing as the parentheses. It's a sort of a grouping sign, and we have to deal with the numerator first here because it has more than one term before we can actually do the division. Okay, let's look at a few more. Our next example, we have a plus 4 divided by b minus 2. And I'm going to have a plus 8 out here. All this we're going to add a to. And we want to know the value of this expression excuse me, when a equals 2 and b equals 3. Okay, so let's go ahead and substitute our values into for our variables. We have a, which is 2, plus 4 divided by b, which is 3, minus 2. We have our plus 8 out to the side, and then plus a, which is 2. Okay, so we actually have a fraction bar inside of parentheses. Don't get excited about this. We're just going to work our way out. Let's deal with our numerator and denominator first. We have 2 plus 4, which is 6. 3 minus 2, or 3 plus a negative 2, is 1, plus 8. And we can simply drop these parentheses because we're just adding this 2 out here. So it doesn't make a difference. We can just drop those and write plus 2. We can take the 6 over 1 and just call it 6. 6 plus 8 is 14. 14 plus 2 is 16. And that's our answer. So let's just take it one step at a time, treating our fraction bars as parentheses, as a grouping symbol, and working from the inside out. Let's say the next one we have 4. We're going to multiply it by the following expression. Let's say we have w minus x plus 4z divided by 2 plus y squared. And let's throw in a minus 2 out here. Okay, we want to know what the value of this expression is when w equals 7, x equals 2, y equals minus 4, and z equals a minus 1. Okay. This looks like a total mess, but we're just going to take it one step at a time, working from the inside out, and we're going to substitute in our values for our variables. So let's go 4 times w, which is 7, minus x, which is a 2, a positive 2, plus 4z, z is a minus 1, divided by, this is getting a little sloppy, excuse me, divided by 2 plus y, y is a minus 4, and squared, and we have our minus 2 out here. Okay, so we have all of our variables plugged in. Now let's go ahead and work from the inside out, treating our parentheses, and we'll go from there. Parentheses first. So we have 4 times 7 minus, 4 times 1 is a minus 4, minus 4 plus a positive 2 is a minus 2, 2 plus a negative 4 is a negative 2, squared, let's not lose our square right here, and we still have our minus 2 out here. And moving on, we have 4 times, well, 7 minus a negative 2, cancel these, it's the same thing, 7 plus 2 is 9, divided by minus 2 squared is minus 2 times minus 2, which is a positive 4. Anytime we square a number, it's positive every time. Then we have our minus 2 outside. We're multiplying a rational number here, so let's go ahead and convert this one to a rational number so it's more easy to deal with. We multiply numerator, numerator, denominator, and denominator. So 4 times 9 is 36. 1 times 4 is 4. We still have our minus 2 out here. We can go ahead and simplify as we go along. 36 over 4 is 9 minus 2, and 9 minus 2 is 7. Okay, so you see we took care of all of our arithmetic operations in our numerator and all of them in our denominator before we can actually do the division or the multiplication. We can actually distribute this 4 at the very beginning, but I think that would be a bit laborious and will make things a little more complicated or confusing. So let's take it one step at a time and always insert our variables for our values before we do anything else. Let's do another one. Let's go 3x squared divided by 2x squared minus 4x and plus 3. And we are given the value for x is minus 2. Okay, so we have a few x's in here, so let's go ahead and plug in our minus 2 into there. So we have 3 x is minus 2 squared divided by 2x, with x is minus 2 squared minus 4x, 4x, so 4 times minus 2 plus 3. Okay, so we got our variables taken care of, so we can take this one step at a time. We can do the numerator and denominator at the same time, and they both have exponents, so let's handle those first. We have 3 times minus 2 squared, which is 4, divided by 2 times a minus 2 squared, which is 4, minus 4 times a minus 2 is a positive 8. We're multiplying two negatives here, gives us a positive, and we still have our plus 3 out here. And this is shaping up for us a little bit. 3 times 4 is 12. 2 times 4 is 8. Plus, we can combine these. 8 plus 3 is 11. And last, we have 12 over 8 plus 11 is 19. Okay, so it's pretty simple when you take it one step at a time and make sure we don't lose any negative signs or make any mistakes. We take it slow, we'll get the right answer every time. Okay, let's do another one. Let's say we have x squared divided by y plus z. And to this we're going to add, let's say we have y squared divided by y minus x. Okay, and we're given the values for the following variables. We have x equals 3, y equals 4, and z is minus 1. Okay. Actually, all we have here is variables. There's no constants, so we're going to replace all these variables with the corresponding values. X squared, x is 3, so we have 3 squared. Y is 4, plus z is a minus 1, plus y squared, y is 4, so 4 squared. Y is 4 minus x, which x is 3. Okay, so now we can deal with the numerators and the denominators separately. We have exponents up here. 3 squared is 9. 4 plus a minus 1 is 3. Plus 4 squared is 16. 4 minus 3, or 4 plus a negative 3, is 1. And we can simplify this a little bit. 9 over 3 is the same thing as 3. And 16 over 1, we can drop the denominator because it's 1. So we can just say 16. 3 plus 16 is 19. I went a little quick with that because we're almost out of time here, but I want to go ahead and get another one in your notes. Just make sure we're plugging in the correct values for the correct variables, and we're watching our signs here. The order of operations will take care of the rest. Let's do one more. Let's say we have x squared plus z squared divided by x times z minus 3x times x minus z. Okay, and we have the following values. We have x equals 3 and z, let's let z equal 2. Okay, what do? Well, we start out by supplanting our values into our variables. X squared, x is 3, so 3 squared, plus z is 2, 2 squared, divided by x times z, so we have 3 times 2, minus 3x, well, 3 times 3, times x, which is 3, minus z, which is 2. And all we have simply left to do is follow the order of operations. In the numerator, we have 3 squared, which is 9. We have plus 2 squared, which is 4. In the denominator, we have 3 times 2 is 6, minus, we can combine these two 3's. 3 times 3 is 9, times 3 minus 2, or 3 plus a negative 2, which is 1. And this is shaping up pretty nicely for us. 9 plus 4 is 13. 6 minus 9 plus 1 is 9. And we have 13 in the numerator. Denominator, 6 plus a negative 9 is a minus 3. So we have minus 13 over 3 as our answer. Okay, we're out of time, but very quickly, what do we learn here? Evaluating algebraic expressions with fraction bars, the main thing we want to take away is that when we see this fraction bar and we have more than one term in either the numerator, the denominator, or both, we want to treat it as a grouping symbol. We want to treat it in the order of operations as the same as the parentheses. So we need to evaluate the numerator and the denominator, whichever has more than one term, before we can actually carry out the division. We need to make sure we get a handle on this because we see this all through algebra. So please review this a few times, and I'll see you soon.